Hi there, my name is John Raymond. I hope today to be able to entertain you with some very interesting news about physics and blended with philosophy. You might say, blending physics with philosophy? That's stupid. I hope by the end of my presentation today that you might see some merit in what I'm saying. I stress for today I'm skimming over information. By no means should you see it as a representation of physics. They're sketches of physics. I'm not seeking to prove anything. I'm just giving you some basic ideas to think about. I've made it as layperson friendly as I can. I am a layperson too. I see myself as an amateur student of reality. My great interest in life has been, especially since 2010, is interested in learning and sharing. I've held some seminars. I have published. I enjoy doing this. But as I get older, unfortunately, I can't do the things I used to do. I cannot be concerned about critics. I know I have many, and they've told me so. But because I am not seeking to prove anything, just to provide thoughts for people to take up and act upon themselves, I don't feel guilty with that at all. My memory's not good. Today I'll probably overlap and I may not even know I'm doing it. I don't always see what I've said before either. So please be patient. Now to the meat of the issues, or should I call to the meat of reality. I'm going to talk about reality. I see there's two different worlds in reality. I see there's an implicit world and an explicit world. I see all things as being information, explicit and implicit information. This will become clearer shortly. This is knowable and unknowable information. And also is that which is observable and measurable, and that which is not. And I think that that's important, and I'll discuss this when I get to the Planck line a little bit later. In physics they have what's called quantum information and subquantum information. I'm primarily interested in subquantum information. These are the things that are going on at a mysterious level in the world around us, that which is very poorly understood in physics, and is only touched upon in some fringe areas of physics like biology. I call subquantum information implicit information. I call that which is quantum information explicit information. In the subquantum world, as I said, it is mysterious. Entanglement theory in physics is critical to this. I think it is the most mysterious of all. This is it. All things in the universe are entangled with each other. And do you know that physics has now demonstrated through experiment that information can be transferred across the universe not over a million years or a million light years, but instantly. That's unbelievable, isn't it? But it is true. There is physics experiments that prove this, as there are physics experiments that prove many of the things that I'm talking to you about today. Some of the things I'm talking about has been demonstrated in quantum physics when mathematics is applied to it. The mathematics predicts that many of the things I'm talking about are true, but they have not yet been proven by experiment. I say that all these things relate to reality. Reality is all that is, both implicit, explicit, quantum and subquantum. The big problem with physicists today is it is true that quantum physics is real, it's true that subquantum physics is real, but the big hassle is bringing the two together. And you might say, well, is that why the universities and the schools are only teaching quantum physics? Well, that is partly true. In some respects, it's largely true because in the politics of teaching physics, it's easier for those that don't understand subquantum physics to avoid talking about it at all. Hence, some of my ideas that I'm sharing with you today are never known about in a person's lifetime I think it's important that you understand that. And another reason why I'm saying to you, just take on board what you hear me saying and then treat it as you feel is appropriate. When we talk about information sharing and information, I think it's important that you consider that don't look at everything in terms of being energy. Of course there's energy, but also if you look at all things, both implicit and explicit, as being influences. Now that gets us off the train of saying this is real, this is not real. What we are saying is this is an influence that affects that. That is an influence that affects this. And this may surprise you, but it is true. Way back in about 1950, there was a physicist by the name of Lorentz. And Lorentz predicted, and this showed up mathematically, that if a butterfly in South America was to flap its wings in South America, the effects of that would be felt on European mainland. Now that's unbelievable, isn't it? Now that hasn't been actually proven by experiment yet, but the mathematics demonstrate that this is possible. Now with the entanglement theory that I've talked about, you might understand that this is possible. And this is especially so in relationship to particle physics, which I'm going to talk about in a moment. People often wonder what the word cosmology means. Well, again, if you think of it in terms of information, cosmology is the understanding of all things in the world, all things in the universe. And it's also possible that there is another universe in different dimensions. So cosmology involves all those things. Very little is understood, of course, and we as human beings could not possibly understand it anyway. We can only understand so much what our brains have been used to reading about, or what we've been taught, or what we've been experienced. There are many variables in all this, of course there is. And one of the things that physics does is they acknowledge there are things, this is in quantum physics, as hidden variables. And if you Google hidden variables, you see where the Bohm theories of physics uses that a lot. Bohm is a well-known, now deceased physicist whose ideas are rapidly coming forward in the international physics community. He was ridiculed at the time, but he was a good friend of Einstein, and Einstein and he got on very well and shared many ideas. It is not generally known that Albert Einstein, towards the end of his life, began to question his own theories. There's nothing wrong. The physicists say there's nothing wrong with Einstein's theories, which is true. But Einstein also had to wrestle with the idea of what is implicit and what is explicit and bring it all together with his theories and his teachings. Now, to finish this, or conclude this section, should I say, of my presentation, I want you to consider this. In my mind, this is one of the weirdest things in subquantum physics that you could possibly ever imagine. And that is this, that if you had a twin, and you and your twin sister or brother decided that, or you decided that you wanted to go for a trip around the universe, and you elected to go on a spaceship to make this journey over a 2-year period. So you said goodbye to your sister or brother, and you said, I'll catch up with you in 2 years' time, and you do your travel around the universe, you get back, and suddenly you both realise that you look different. And do you know what the reason for that is? And this is really unbelievable, at least in my mind it is, and that is you have aged in your spaceship at a lesser rate than your sister or brother on Earth. The reason why is because you age within the confines and really the relative environment of the spaceship, whereas your twin sister or brother age in relationship to being on the Earth. Like many things in physics, it also stuns me that if you had a steel rod and move it through the atmosphere, it shrinks slightly. Anything you move shrinks slightly. That comes into entropy theory in physics. Now, when you say it shrinks or it expands, This is in a very, very small degree. It might only be a trillionth of a millimetre, but the fact that it does it is true, and this was demonstrated by an experiment that took place in the 1920s. So now I'd like to touch on some of the things which I'll call it a discussion, which I hope you'll find fits into some of the preamble that I've just given you. I'll commence this way. It was around 2010, as a layperson, I started reading about physics, and I was immediately drawn to subquantum physics. And it's because of that that I still do believe that there's a relationship between subquantum physics and philosophy. As I indicated earlier, physicists do not talk with one tongue. Why? Because some physicists are prepared to look at the bigger picture, as I'm sharing with you today. Those that are prepared to listen and do their own research, they will also find, as they have done, that they can get to the bottom of some of the great mysteries in life. And as I said before, mathematics predicts a lot of this. We can never forget we all live in the world, don't we? Some of us forget that, because to live in the world we also have to think about the things like intuition and consciousness, and what happens to people when they have near-death experiences and they can remember things. Was that all daydreaming? I'm sure some of it might have been, but I'm also sure a lot hasn't been. A lot of people that have had clairvoyance with mediums, they also agree that they got messages. I'm not saying they're right or wrong, I'm just asking you to consider these sorts of things. Now, in relation to this, I think that to make things easy, what I did some time back when I started thinking deeply about these things, I discovered the Planck line. Now, a Planck line is postulated by a German physicist by the name of Max Planck. This was around 1900. And Max Planck he said that there is a point or a line in reality where things are measurable and things were not measurable. So this, in my mind, is the line between that which is implicit and explicit, because it's clear-cut, and I think when I show you this diagram as I am now, you might picture what I'm saying. The middle line, or the two lines, if you imagine that to be a black line, I've called it the Planck line. And above that, I've got, as I've indicated to you, that which is explicit, which is quantum, and that which is implicit, which is subquantum. So that becomes the definitive line in which I'm talking to you today about reality, and why I've talked about implicit and explicit reality. So I think that also helps us to understand what reality is. And reality is all information that relates to the universe. All that is knowable and unknowable. I think it's important that you remember all these things. In finality, I've talked about there being experiments that prove this and prove that. Now, many of them are beyond my comprehension. All I know is that they do exist. But there's one in particular that I'd like to share with you because it's been known about for many decades and it's been proven multiple times. It's called the double slit experiment, because this brings to account what I've been saying earlier, and also it demonstrates that this mystery, especially with particles communicating across the universe, is quite possible. There's a discipline of physics called particle physics. Now, particle physics is about particles in the universe. The universe is made of particles. Not only particles, but principally all material things, including us, are mostly made of particles. Rocks have particles. Everything has particles that is alive. And of course, it's far wider than that, but I won't attempt to explain it because I'm sure you know what I'm talking about. But I think what is critical in all this, it's been demonstrated, as I'm about to point out, that particles have their own mind. Each particle as minute and trivial as they may seem, they have their own mind. And this can be shown by the famous double slit experiment. And I'll briefly explain this double slit experiment with you. And that is, if a photon is fired, or a package of photons is fired at two slits, and the slit can be anything, made plastic, cardboard or whatever, the photons or the particles of photons, as they're fired at the double slits, they individually make decisions as to whether they're going to go through the slits as either a wave or a particle. And in doing this, what happens is that if you put a screen on the other side of this double slit, these patterns show up, and they can only be seen by very close experiments, observation, but they are there. Those patterns can be many different things, but the facts are this: that these particles can become waves or particles at their own will. And they make the decisions as to whether they're going to do this or do that. They make the decisions as a system. They make the decisions as groups of particles. You see why this is important, because especially when you bring this to account, that particles can communicate with each other across the universe, this seems to me to mean something very important, that is, the universe is conscious of itself. The particles in the universe are conscious of themselves, and they, in fact, the particles are part of the wider system of all that is real, all that is reality. Keep in mind what I said before about reality. And of course, this also includes explicit and implicit information. So when I talk about the double slit experiments, what I'm saying is that the act of observation, by looking at this, it's visible as to what's happening with the particles. But there's one other footnote to this, and this is probably more important than all things. It's been demonstrated in physics that the person conducting the, or person or persons conducting the experiment, the mere fact that they're conducting the experiments, they can actually influence the outcome of the experiment. If you were in a room watching what these experimenters were doing, you too could influence the experiment. Trivially, yes, but it's been demonstrated by experiment that this is fact. And of course, what does it mean? As I said before, all these things mean influencing. And that's why for my presentation today and any other presentations, I don't talk about energy, because it just makes it far too difficult. But no one can deny the fact that there's influences going on, and that's across the universe, it's across the fact that I'm talking to you today, you're listening and watching what I'm saying on this presentation. Everything influences. And as I said before, there's the butterfly effect, as envisaged by Lorentz all that time ago. So that's the conclusion of a presentation. Keep in mind as I leave you that we are mostly made of particles. We are influencing ourselves, we're influencing others, we're influencing by the butterfly effect, if Lorentz is right, everything in the world. And then you might imagine from this why things are difficult in the world as they are at the moment. Because there's packages of information occurring here, packages of information there, there's conflicts going on, and one thing leads to another, and of course one might say from that this also influences our health and well-being. And that's partly why I believe that my presentation at this time is important for you to think about. I hope that I've not confused you. Remember again, what I'm sharing with you are purely for you to consider and think about how there might be implications of them in your life. And perhaps importantly, may I say it once more, don't forget the butterfly effect. This is when you're talking to others, when you're talking to your dog, or talking to anything at all, or even just thinking about them, because you are creating influence on the bigger picture. It's my intention to create more advanced lines of thinking in this physics science arena. Not that I'm really capable of taking you too far with it, but I've got lots of other ideas that I think you might be interested in. Do have a great day, and remember, for the reasons I've given you, it's okay for you to romanticize.